Good morning, Math Ninjas. We're talking about dividing rational numbers. So at this point, we've done addition, subtraction, multiplication, and now we're looking at division. You guys have done long division already in your mathematical career. Here in our time together, we're not going to spend a lot of that. The important thing is if you are doing pencil and paper long division, that you're really mindful of place value and mindful of your decimal point, okay? So here's a problem. Take you some time with pencil and paper. I'm going to emphasize again the importance of estimating, okay? Especially with a type of problem like this where there's lots of room to make an error with it. Okay, so the squiggly sign, squiggly equal means approximately. And so here, if we're looking at a negative 6 8/10, we're going to say that's approximately 7 divided by, and you could say if you're, I like to estimate to halves, not just straight up or down to a whole number. So I'm going to say, and that's a negative 7, I'm going to say divided by a negative 3.5, which also works out pretty good. So negative 7 divided by a negative 3.5 goes in twice, right? Also a negative divided by a negative, the signs are the same, all be positive. Okay, so it's approximately a positive 2. Now we got a calculator. We use this in our life, so we can go back and negative 6.8 divided by a negative 3.6, and I've already determined that what that was. So it's going to be equal to 1 and 88/100 repeating. And so what's the symbol for repeating? The little bar on top of the number that repeats. So you could have just done it at the tenths. It doesn't matter too much. So our exact answer is 1 and 8/10 repeating, 1 and 8 repeating. Okay, so importance of estimating. We're not going to do long division. If we needed to, I would tell you, practice your long division and we look at one together. At this point, I'm not doing that. Okay, next, we are doing fractions, dividing by fractions, okay? So first, because there's another sort of funky rule with dividing fractions that you're going to use almost always. So first, I want to look at a logical, a really straightforward example of division. And like multiplication, there are times when it will work. Divide straight across. 3 divided by 1 is 3. 4 divided by 2, the denominator 4 divided by the denominator 2 is 2. Our improper fraction is 3/2. Super simple, right? Okay. Now, this works too. And what this is, I'm going to throw out some language here, so hold on. Okay. Reciprocal. Reciprocal. Let's come all the way over here. Let's write the word reciprocal. Okay. This is an important math term. Okay. So I want you guys to know it, read over it a few days in a row till you memorize it. Two numbers whose product, so when you multiply them together, is equal to 1. So reciprocal, 2 products, multiply them together, you get 1. So for example, we're just going to keep this super simple. If you had 1/2, you would multiply that by what's going to equal 1. You basically are flipping the denominator and the numerator. So 2 over 1. So multiplication, multiply numerators, multiply denominators. 1 times 2, 2 times 1 is equal to 2 over 2, and that is 1. So reciprocal numbers, two numbers whose product is 1. Know it, believe it, memorize it. Okay, so let's go back and let me show you this rule, this algorithm, this procedure that works with dividing fractions. So you have 3/4 divided by 1/2. You can multiply by the reciprocal. 3/4 multiply by the reciprocal of this second fraction, 1/2, multiplied by 2/1. This works, it's a pattern. And now we are going to multiply. 3 times 2 is 6. 4 times 1 is 4. 6/4 simplifies to 3/2. Notice that our answers are the same. So here it is. I'm going to spell it out. You can multiply by the reciprocal. So you can multiply by the reciprocal when dividing fractions, okay? Know it, believe it, memorize it, practice it, prove it to yourself, but you're going to want to be comfortable doing this, okay? So let's look at one more example. Okay, so if you had 7/9 divided by, let's say 2/5, and that's gonna be, we're not sure. In this case, it doesn't work out too cleanly. You could go to decimals or whatever. 7 divided by 2, 9 divided by 5. Still, we want to work with this multiplying by the reciprocal. So it's division. There is a rule, a pattern, an algorithm that works. 7/9 multiplied by the reciprocal of 2/5. And here we go, pausing at our ed puzzle. What is the reciprocal of 2/5? So multiplied by 5/2. And why, you ask? Because 2/5 multiplied by 5/2 is equal to 1. Do you want to see it? Okay. 2/5 multiplied by 5/2 is equal to 10 over 10 is equal to 1. Okay, so there it is. All right, so now we're going to multiply. We can do this, and we get 7 times 5, 35, 9 times 2, 18. Are there any common factors? 1, 2, 3, 6, 9, 18. No, 35 is just 1, 7, 5. So no, so this is actually done. 35/18 is our deal. So 7/9 divided by over half divided by under half is, sure, 35/18. If you're doing that estimation in your brain, I think that works. All right, dividing rational numbers. There it is, Math Ninjas.